Okay, so let's just take a few minutes to recap what we've done so far with our quantum numbers. So we said our first quantum number is the n number, and this is equivalent to the shell. So when we're looking at our periodic table, and I would go ahead and print this out so that you have a copy of it in front of you, the n number is going to be the period or the row number. So we can write n right here, and you can see that there are 7 possible shell levels, and so they're represented by these numbers here, 1 through 7, and they correspond to the rows or the periods on the periodic table. So that's our shell, that's our highest level. We said this was equal to the whole apartment complex when we're defining our address for where the electrons are going to live. So the next level is the L number, and this is the subshell. So these are the subshells, and we said that these are equivalent to the apartment buildings. And so within each shell, there is a range of possible subshells that can exist. So we said that there's 4 possible types. There's the S subshell, the P subshell, the D subshell, and the F subshell. So these are our 4 levels of possible subshells. And for each n number, so if we start out at the center, so this would be the protons and the neutrons, or the nucleus of the atom, then our different layers are going to expand out from that central point. So these would represent our n numbers. So the most inner shell is the n of 1. The next shell out is going to be 2, and the next shell out would be 3, and so on. Up to 7 shells can be possible layerings where the electrons can exist around the atom. So because this inner shell is so small, and it's the closest one to the nucleus, it cannot house very many orbitals, and so it only has essentially one apartment building. The first subshell, so subshell number 1, only has an S subshell. The second layer out, number 2, has both the S and the P subshells, or the S and the P apartment buildings. The third subshell out has S, P, and D subshells, so it's a bigger apartment complex. And 4 has S, P, D, and F subshells. Then layers 5, 6, and 7 all contain these 4 possible subshells. So from 4 up, we've got S, P, D, and F possible. Okay, so the next level is the M to the L number, and this is going to represent the number of orbitals per subshell, or per apartment building. So this is equivalent to number of apartments in the apartment building. So the S apartment building, or the S subshell, is the smallest. It only contains 1 orbital. The P subshells contain 3 orbitals, or 3 apartment buildings. The D subshell contains 5 orbitals, or 5 apartment buildings. And the F subshell contains 7 orbitals, or 7 apartment buildings. And then the final level of complexity, or the last quantum number we talked about, was the M to the S quantum number. And this one represents the number of electrons per orbital. Okay, and so, or this is the number of people per apartment. And so we said that this is maxed out at 2. So you can only have 2 electrons in each orbital. So if we're looking at the S apartment building that has 1 orbital, it can house a total of 2 electrons inside that apartment building. If we're talking about the P subshell, it has 3 orbitals, and so this can house a total of 6 electrons. So this is like having 3 apartment buildings, and you can have 2 electrons per apartment. And so you've got 3 apartments, you can have a total of 6 electrons. So for the D subshell, this apartment building has 5 apartments or 5 orbitals. So we can have a total of 10 electrons that would be present in this apartment building, because there's 5 apartments, 2 electrons per apartment possible. And then in the F subshells, there's 7 orbitals, so we can have a total of 14 electrons housed within that complex.